All right, we're going to look at calculating correlation coefficient in this particular scale. And remember, when we are talking about correlation coefficients, we're trying to find out the strength of the relationship between the input of data and the output or the result of the data collected. And we want to really see how much one influences the other. So we'll just go ahead and get started. The deeper explanation is in the other notes that we have for this. So I just wanted to kind of take you through some calculator run through with this because this is a particular skill that you can do by hand. However, it is much more expedient with the calculator. So we're asked to find the correlation coefficient, which is R, of the data described below. A professor wants to know if a student's first exam score can be used to accurately predict his final or her final exam score. He looked at how many times some of his previous students did on their first exam, which is X, so first exam scores. He also looked at their final exam scores, Y. Both exams were graded out of 100. So we want to see how strong the correlation is between the first exam score and the final exam score. So we're going to go to new document, make sure our calculator is clear. Let's go to lists and spreadsheets because this is a list and we can put it in a spreadsheet. So our first column, we're going to name this X just in the interest of time. You could name it first. And the second column B, you could name it final if you wanted to do that. I'm not. I'm just going to name them X and Y. So we've got 47, 54, 66, 67, and 72. Then I'm going to go on up to the B column, and I'm going to put not X in there. Delete that. I'm going to put Y. And then I'm going to put the second set of data here. That's 43, 61, 88, 92, and 80. And make sure your data is in there. You know your data is in there when you have this blue box on the bottom. Hit menu, and this is statistical data. So we want to go down to statistics, and we want the calculation of the statistics. So at this point, you can either push the right arrow or you can push enter. We want a linear regression, and we're going to use mx plus b because we're familiar with that. You also see a linear regression here that says a plus bx. The difference between the two is mx plus b, the slope is written first. If you use the a plus bx, then the y-intercept is written first and the slope is written second. So again, we're going to use mx plus b because we're very familiar with that. Hit enter. In this first portion where it says X list, we're just going to use our X data. In the Y list, we're going to use Y. Then you're going to skip through all of these cells. And at the bottom, you need to make sure this always says C or greater, never A or B. Because if it says A or B and you try to calculate, it will take some of your data out, and we don't want that. So we're okay with how it is. And if you notice, once we push enter, we were given the information in mx plus b form, which is slope intercept form. We were told the slope is 1.80459. Here, the y-intercept is negative 37.64 or 641. And what we're looking for is this R down here. This R squared, we use that later in statistics. I don't want you to be concerned with that right now. So R is equal to 0.909896. Now that looks wonderful. I want to caution you though, sometimes the inspires round before you round. So instead of using that number, what I'd like you to do is go ahead and go on down to the cell, and I want you to notice this number on the bottom. That is the number that I want you to use to round. So number one, we are told is 0.9098. And here we're told that we're going to round to the nearest thousandths. So if you remember, the first place behind the decimal point is the tenths place. The second place behind the decimal point is the hundredths place. The third place is the thousandths place, excuse me. The fourth place is the 10,000th, and we're going to use the 10,000th place to determine what we should do with the thousandths place. Now, if I round this, I've got 0.9. Well, this 8 will make this 9 go up to 10. So instead of writing 10 right here, I'm going to write the 0, and I'm going to write the 1 here. So this would be our answer rounded to the nearest thousandths place. So that's 0.910. Oh, I didn't mean to type it there. I meant to type it here. 0.9. I was typing in the calculator thinking I was typing on the computer. All right, so that was number 1. Let's look at number 2. I'm going to clear out the calculator by pushing New Document. And again, we're going to go to Listen Spreadsheets. And we're going to get ready for our data. So on today's episode of Science Time with Spencer demonstrates that walking speeds affect how wet a person will get in the rain. He simulates walking through the rain at various speeds. Spencer keeps track of his walking speed in meters per second, which is notated or represented by X. Next, he measures how wet he is by taking the difference of his weight before and after walking through the rain in kilograms, which is Y. So we have the walking speed and we have how wet or how much water he has absorbed after walking through the rain. So I am going to just title my first column as X, and I'm going to put the data in. 1.2, 1.7, 1.7, 1.9, 1.9, and then I go up to B, and this is going to be my output, which is Y. So that'd be 1.9, 1.4, 0.5, 1.2, and 0.2. And then we're going to hit Menu, Statistics, Stat Calculations, Linear Regression. Now let me explain what a regression is. A regression is taking the data and going back to the original equation that it came from. If you notice, we are normally used to having the equation and substituting points to find out what our outcome is. We're just moving backwards. That's what a regression is. So we have our X list, we're going to put X. Our Y list, we're going to put Y. Go ahead and tab all the way down. Make sure the first result column is C or greater, which it is. So we're happy with that. We're going to say OK. Our slope is negative 1.72561. Our y-intercept is 3.93902. And this is what we want right here. Negative 0.7184. Now I want to make sure that it's the same here. Negative 0.7184. Remember I said use this number down here because sometimes IXL will round for you and then you'll think you need to round again and it'll be counted wrong. So I've got negative 0.7184. We're going to use the 10,000ths place to decide what to do with the thousandths place because we're asked to round to the nearest thousandths. Well, this 4 is less than 5, so what I'm going to do is I'm just going to drop that. And so our answer would be negative 0.718. Let's go ahead and look at number 3. Martin thinks that text messaging is causing him to talk less on the phone. For 1 month, he examined his text messages and call logs with his closest friends. For each friend, Martin checked the number of text messages he sent to that friend, which is X, and the number of minutes they spoke on the phone, Y. So again, let's start all over. We're going to go to the On button. We want a new document. No, we do not want to save our previous document. Go down to List in Spreadsheets and start entering your data. So we name the first column X, and then we put in our data. 37, 40, 42, 81, 94. Let's go up and put in our Y data. 60, 84, 87, 66, and 45. Menu, we're going to do stat calculations. We want the MX plus B. We want our X in the X list, our Y in the Y list. Tab down. That's C or greater, so we're happy about that. We want this information here. We want the R. And we've got negative 0.6997. And again, we're going to round by using the 10,000ths place to tell what to do with the thousandths place. Well, notice this is 7, so that's greater than 5. That changes this 9 to a 10, and when we change this, it's going to change this as well, and it's going to change this as well. So our new number would be 0.700. Now, we talked about strength of correlation. What I want you to notice, and I didn't really talk about this at the beginning when we did the first problem, but here, this 0.910 is a very strong correlation, meaning if we graph the points would be really, really close to the line. This one was a medium correlation. In other words, it's not really tight on the line, but it's not loose on the line. This one also would be a medium correlation. So anything above, I'd say 8 to 1 or negative 8 to negative 1 would be strong. Anything between, I'd say 5 and 7, or even possibly 4 and 7, would be medium. Anything less than 4 is going to be weak. So here is what we're going to do. We're now going to type in our answer. It is negative 0.700. We're going to do one more in the interest of time. So we've got Wayne and Hakeem are judges for the Burlington Ice Skating or Staking Federation. Due to claims of malfeasance at recent competitions, a reporter is investigating the relationship between the scores awarded by the two judges. Malfeasance, mal, the root word means bad. So basically they're saying, oh, something is not right here. Something is very wrong. That's what they mean by malfeasance. So he has collected the scores awarded by Wayne. So that's in the X column, and Hakeem in the Y column for each performance in the last competition. And again, we're going to round our answer to the nearest thousands. We're looking for if there is a strong correlation between Wayne's score and Hakeem's score. But here, when we answer this particular question, we just want to know what that correlation coefficient is. So we're going to start over. We want a new document. No, we don't want to save the old. We're going to list in spreadsheets. Now, you're going to be using this when we do quadratic regressions as well. So keep this in mind. When you see list in spreadsheets, you can use them to regress linear functions and get the slope of a line. You can use it to get the correlation coefficient. This is good for all kinds of things. So we've got 0.9, 1.9, 2.7, 3.9, 5.3, and 5.7. I'm going to go up and I'm going to name this column Y and put in the other data 0, 3, 5, 3, 5, and 0. Now, if you hit enter, I want to show you something. When you put menu, when you do stats, see how all this is gray? That means that you're expected to put some data down here. Well, I'm not going to put any data down there, so I need to go back and fix that. I'm going to escape there. And I'm going to go back up to 0 and come back down and make sure that that's blue. So statistics, stat calculations, we want linear regression in y equals mx plus b form. The x list is x, the y list is y. Tab down, we need to make sure our first result column is C. We're okay with everything that's there. And we're going to come down to R. So here we have 0.1399. We're going to use this 9 to determine what this 9 should be. So we're using the 10,000ths place to determine what the thousandths place should be. And because this is greater than 5, this goes up 1. And so what happens is it goes up to 10. Well, I have to do something with the 1 from the 10, so this is going to go up 2. So our answer would be 0.140. Now, this is a very weak correlation. It's not even close to 1. So the person, when they're investigating, they're probably going to say, there's no claim to this case. So that would be that. Now, I'm going to stop right here because this video could take about 30 minutes explaining every step, but we've done enough for you to see how this works. And we'll move on to the next lesson. Have a good night.